let's get started. I would like to introduce KYZEN's own Jack Reinke.
Thank you, Sherry, and thank you all for sitting in on this episode of KYZEN's Tech to Tech series, short weekly presentations on the basics of cleaning. Today's discussion revolves around flux management in typical aqueous inline and batch spray cleaning systems, the influence of that flux on cleaning, rinsing, and bath life, and how to best manage that flux over the life of your wash bath. Here we see a clean, fresh wash bath on the left, one that's heavily soil loaded on the right. This fishbone diagram describes all the factors influencing cleaning, from soldering materials and the components that are mounted or populated on the circuit card, to the cleaning chemistries and assembly materials, and everything in between, all of which has to be considered to achieve acceptably clean electronics assemblies, more importantly, to avoid costly scrap. KYZEN's electronics cleaners are designed to dissolve reflowed flux residues and hold them in solution, so they're not readily removable by conventional mechanical filtration. Membrane filtration or reverse osmosis is an aqueous cleaning process, but it's expensive, it's challenging to control, and not very practical. So inevitably, open the closed loop and send something like the KYZEN to drain, the best option over the sophisticated membrane technology. The good news, however, is high wash concentrations can serve to extend wash bath life, and I'll talk about that a little bit later. Successful cleaning begins with solubility. Match the cleaning agent with a solder paste. In this case, we've got the same solder paste introduced into several cleaning agents, and you can see the rather dramatic difference in the effect those agents have on the same solder paste. So make sure you match the cleaning agent with the solder paste so that you're assured dissolution will take place to remove the reflowed flux residue from the paste in the cleaning process under the right conditions, concentration. Call it match the hatch, as a trout fly fisherman might say. Here we've got flux loaded, controlled flux loaded into several cleaning agents mixed up at 10, 15, and 20% concentration. And under both static and shaken conditions, you can see the rather dramatic difference in the appearance of these materials. These are clues to how free rinsing these wash solutions will be when loaded up with about 1.5% flux. Every cleaning process reaches critical saturation, or a point when the dissolved soils start to affect cleaning, and more importantly, when those dissolved soils start to hinder rinsing. Using surface tension, shown on the left, and contact angle measurement device on the right, we can assess the rinsability of wash solutions when fresh and loaded. In this case, cleaning agent B shows a lower contact angle and a higher surface tension than cleaning agent A. Those two factors, the lower contact angle and the higher surface tension, means that wash solution will rinse easier. So hence, cleaning agent B, in this case, will rinse more freely or better than cleaning agent A. This is from a study conducted jointly by Lockheed Martin and KYZEN for the SMTA High Reliability Cleaning and Coating Conference in 2018. And for more information on the importance of rinsing, you can look up a previous Tech to Tech by our Vice President of Global Technology, Ram Wissel, from last August, I believe it is. Beyond reflowed flux residues, we know there's a lot of other contaminants that get into the wash bath, including but not limited to water-soluble masking tape, solder mask, adhesives, Kapton labels and arrows, raw solder paste, which is never supposed to go into the wash bath, but oftentimes does, tiny screws, and even stray components that get knocked off assemblies. Most of these particulate contaminants are removed in circulation filters, catch screens underneath the wash chamber, or even the strainer on the wash pump uptake. But bath life is based on dissolved flux residues in solution at a specific rate dependent upon the cleaning agent concentration, bath temperatures, and spray pressures. You can measure flux load by non-volatile residue, or NVR testing. You can do that in-house with a device like that shown on the left, which is a Mettler-Toledo moisture analyzer. Generates results in minutes, or you can collect samples, wash bath samples, and send into your chemical supplier for full analysis, including NVR. But wash solution lost by drag out, exhaust, and the corresponding replenishment or the makeup required to account for those losses has a huge impact on bath life. Let me explain. Here's an example of linear soil loading. This would be in a static system where you have a ceiling or a critical soil load. As the soils are loaded in over time, it's a straight line relationship. We know exactly where it's going to reach critical load and exceed the wear out the bath. We know it's not a static system though. All of these cleaning systems are dynamic, and because we have drag out and makeup to consider, we can actually manipulate the loading rate. Drag out and exhaust losses. This is an example of how drag out takes place, where the soil laden wash solution is on the part. A certain fraction of that wash solution exits on the part, then has to be made up with fresh chemistry and clean water. So essentially, there's a purge that takes place continuously through makeup for drag out and exhaust losses. So let's look at this now as a dynamic chart. Instead of it being a straight line as the soil loads, it's a curved line. You still have the critical soil level that you don't want to exceed, but now by increasing your drag out, you can actually drop that line. Another way to put it is you raise that critical soil load. So what does this mean in reality? Well, we can take this phenomena, look at this bath life simulation. The chart on the left shows that the top line, the pink line, is a bath life normal, where the machine is buttoned up tightly and running as low a concentration as possible, where loading reaches a critical soil level sooner. You see it cross over that straight line at about 4. This would probably mean more often, changing out the bath more often, maybe weekly. The second scenario is in the yellow line, is bath life optimal, where you have a little more drag out and exhaust loss. You're running a medium bath concentration, so you might have to change out monthly instead of weekly. And then the best case scenario is a higher drag out called controlled drag out, a higher wash chemistry concentration, so that the bath reaches a steady state and never really gets to that critical soil level. So change outs really aren't warranted except during preventive maintenance. This concept is known as bleed and feed. It uses a little bit more chemistry, but can avoid the rigmarole of frequent bath changeouts. This also gives some credence to the phrase, you never have to change out the wash bath, because in effect, you're turning that bath over regularly by your makeup for drag out and exhaust losses. Wrapping up then, critical cleaning and defluxing circuit card assemblies is growing ever more important, demanding high throughput, long and effective bath life, and environmental responsibility. And with that, I'll turn it back over to Sherry for questions.
Thanks, Jack. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@kyzen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.